Intro Algebra Lesson 4-4A. All the time that we've been spending now graphing, we've focused on using input-output tables. We've looked at the ability to find x-intercepts and y-intercepts to make graphs. Now we're going to look at a little bit more detailed piece that's pretty crucial to every linear equation that we'll come across. And that is the idea and the concept of slope. We will refer to slope as the letter M. I know that seems strange to use the letter M, but we don't want to use S because it could be mistaken as possibly looking like a 5 when we write it or some other things. But M is universally well known that that's going to be our slope. We refer to slope as rise, and rise represents up and down. So up is positive and down is negative, just like on the y-axis. When you go up it's positive and when you go down it's negative. Over the run, what we call the run, and run is left to right. So when you go left it's negative and when you go right it's positive. So it's really going to look like a fraction. Slope is going to look like a fraction. Alright? I'll tell you some very basic mistakes that are made with slope. People don't pay attention to the up, down, left, right, so they get the positive and negative part wrong. The other thing they really make the biggest mistake of is they accidentally put the run, or the left to right action, on top of the rise. So you've got to watch those details. Rise, up and down, over the run, left and right. Alright, so here's an example. We know we start off with rise over run as a fraction. Rise is the up and down, run is the left to right. So let's say we had a fraction and we said it was 4 over 3. So that's the fraction 4/3. We really don't want to turn it into a mixed number of 1 and 1/3 because that doesn't help us with the whole rise and run piece. What we're saying is it's going to go up 4 and then it's going to go right 3. And that's what the graph will do. So from one dot to another dot on the linear equation it'll go up 4 and over 3. From that dot to the next dot it goes up 4 and right 3. From that dot and on, up 4 and right 3. And it will do this continuously as long as that equation goes on forever. Alright? So, rise over run. Again, up and down over left to right. It is known as the change in the y over the change in the x. Let's say I'm standing on the ground here and I'm at sea level. Sea level would be 0 feet above sea level because it's at sea level. And I went up to the mountains that were 10,000 feet. My change in elevation, remember my change in my y since y is up and down, my change would be I went up 10,000 feet. That would be a positive 10,000. Now in order to do that, I also have to go inland from the beach. So maybe I go in, another 80,000 feet. I go inland 80,000 feet. So I went up 10,000, but I went over 80,000. So I would have some slope. I would have rise over run. I would have change in both of those values. The change over here is that there was a rise of 4. That was a change in the y value. There's a y value here. There's a new y value up here. Then there was a change in the run. It went to the right 3, so the x value changed. Alright? And we have a formula for this. And this is a tricky formula for some people because they put things in the wrong locations. We say these little numbers as sub-numbers. Think like a submarine is always down below under the water. So you would pronounce that as y sub 2 and y sub 1, x sub 2, x sub 1, and it's subtraction. Again, there's 4 values. This is what we would use if we had 2 coordinates. And that's what we're going to look at more specifically in our next few examples. How to use that formula. Alright? So here we go. We want to know what's the slope if we have these 2 coordinates. I'm going to look at it from a couple different perspectives. One thing I'm going to use is the formula. We know the formula for slope is y sub 2 minus y sub 1 over x sub 2 minus x sub 1. And it is imperative that you put things in the right location. So here's my suggestion for you. Label these. Alright? So we know that we have, for all coordinates, where coordinates are made up of x and y. Since this is the first coordinate that I have, I'm going to refer to it as the x1 and the y1 that we're referring to up here. This is the second coordinate that's been given, so I'm going to refer to it as the second x and the second y when we're talking about up here. So I will label them. This is my x sub 1. This is my y sub 1. This is my x sub 2. This is my y sub 2. Now you do have the freedom, if you wanted to, it wouldn't be against the rules to call this the x sub 2 and the y sub 2. You could do that. And you could call that the x sub 1 and the y sub 1. It would have no effect whatsoever on your answer. But what would be an issue is if you called this the y sub 2 and this the y sub 1. Now you'll notice you can't mix the sub 2 and sub 1 numbers together. That's a problem. Just like you can't mix them over here. And another problem would be if you accidentally labeled them both as x's and the other ones both as y. So you've got to be careful. That's why I suggest that you just take the first coordinate that's given to you and call it the x sub 1, y sub 1, and the second coordinate that's given to you, the x sub 2, y sub 2. If you do that, you'll be pretty safe until you get comfortable with the formula, and then maybe you can branch off a little bit. So here's what I always do to start. I write m equals and I draw a line and put two subtraction signs in it. The reason I put two subtraction signs is because there's two subtraction signs in the problem. I may choose to change them to plus the opposite later, but for right now I got to put values in the right spots. So when I look at the equation or the numbers that are given to me, I know in the formula that y sub 2 is supposed to go right here. And I've labeled y sub 2 as 2. So I'm going to put that 2 right here. And I know in the formula y sub 1 is supposed to go in the top right. And I've labeled this 0 as y sub 1. So I'm going to put that 0 right there. I know on the bottom left corner I have x sub 2. I've labeled that 0 as x sub 2. And I know in the formula it's x sub 1. And I've labeled the 5 as x sub 1. I'm left with some pretty easy math. All I have to do is finish the problem. 2 minus 0 is 2. And 0 minus 5 is negative 5. Therefore, my slope is going to go up 2 and left 5. That's the slope. Alright? Now imagine, if somebody had changed the order of these, and you had made this x sub 1, y sub 1, and this x sub 2, y sub 2, all that would have happened was the top numbers would have flipped, and the bottom numbers would have flipped, and you would have had 0 minus 2 is negative 2, and you would have had 5 minus 0, which is 5. It is okay to change both the signs. It's the exact same slope. Alright? Let's look at this again in another way. I'm going to look at it on a graph. So we have two coordinates that were given to us. The coordinates were 5, 0, and 0, 2. 5, 0 is right here. 0, 2 is right there. And if you think about it, it goes from this coordinate to that coordinate, it goes down 2. And it will turn and go to the right 5. So there's the slope of down 2, right 5, right there. But if I start at this point, I would go up 2. But I couldn't go right now, I have to turn and go left. When I go left, it's negative. So there's the slope 2 over negative 5, or the slope negative 2 over positive 5. They represent the exact same line. So it would not matter which one you went from, here and up and over, or here and down and right, it produces the same slope. Remember this concept about fractions. 2 over negative 5 is equal to negative 2 over 5, but that is not equal to negative 2 over negative 5. So you do have to be very careful about that. Those are not equal to each other. If one of them is negative, that's fine, but just can't be both. And that's how we would use the slope formula. So if you prefer to graph them, you can count the rise over run, or you can use the formula. Either method works. All right, let's take a look at another one now. Same deal. I would label x sub 1, y sub 1, because that's the first coordinate. X sub 2, y sub 2. We know we're using this formula. Y sub 2 minus y sub 1 over x sub 2 minus x sub 1. And we go from here. I start off, I always write m equals a line with two subtractions. I have labeled my y sub 2 which is right here on the top left, as negative 3. I have labeled the top right, y sub 1, as negative 2. And you got to be careful. That's why I put the subtractions in first. Sometimes people don't want to put the subtraction in and they think it's right here. This is minus negative, so you have to watch your signs. X sub 2 I've labeled as negative 7, and x sub 1 is negative 4. Plus positive, and do your math. Negative 3 plus a positive 2 is negative 1. Negative 7 plus a positive 4 is negative 3. And it wouldn't have been any different if I'd have switched both of them around. I can't just switch one. But if I'd have reordered so that this x sub 1 and y sub 1 were over here, and the x sub 2 and y sub 2 were over here, I could have flipped it around, and I would have ended up with 3 over 1. Remember, if you change one sign, you have to change the other sign. Oh, that's not right. Sorry. You got them mixed up. 1 over 3. So either both negative or both positive. So it's either going to go down 1 and left 3, or it could go up 1 and right 3. But either way, it's going to go from this coordinate to that coordinate. It's the same slope. Almost like a staircase. It goes up and over, up and over, up and over forever. Now, you can tell when you glance at a slope some generic pieces of it. For example, all right, slopes of different types of lines. Anytime the line is diagonal, you want to read it from left to right. So as you read it from the left side to the right side, it goes up. That's considered a positive slope. Now, if you're being asked what the slope is, you can't just say positive. You're going to have to say something like this, where we have an actual slope, a rise over run like a fraction. All right? If you read it from left to right and it's going down, that's a negative slope. Again, if you're being asked, what's the slope of this line, you can't just write negative. You have to actually count and go, well, it goes down 5 and it goes right 6, so that would be negative 5, 6. You'd have to come up with an actual fraction. Now, when they're diagonal lines, it's either positive or negative of some fraction. But there are still some other special situations. For example, anytime you have a horizontal line, your slope is always 0. And the reason? You have no rise. You don't go up at all. You don't go down at all. It stays flat. It has run. It moves left and right. So imagine if you're doing rise over run, you would not go up at all. You wouldn't go down at all. Your rise would be 0. And if you went left or right, any number, it doesn't matter. 0 divided by any number, remember the fraction 0 over something, a rise over run? 0 over 5, 0 over negative 2, 0 over a million. It wouldn't matter. It would always be 0. 0 divided by anything is 0. So if you have a horizontal line, your slope will always be 0. You can look right at it and instantly, oh, that slope's 0. And if you have a vertical line, now these usually get mixed up. Or people sometimes think that on a vertical line the slope is going to be 0, but it's not. This is different. Think about it. Now you have rise. Now the line goes up or the line goes down some amount. But what it doesn't do is go left or right. So your left or right value is 0. And if you take any number and try to divide it by 0, you're going to get an error. If you try it on a calculator, it will say error. Because you can't divide things into 0 equal pieces. So we can't divide by 0. So if it's diagonal, it's either positive or negative of some fraction. If it's horizontal, you know it's always 0. And if it's vertical, you know it's undefined. And you could abbreviate it and say UND. So automatically when you look at it, you'll know it's undefined. So that's how we calculate slope. Just be very careful of where you plug values in to that slope formula. If you practice it and you concentrate on where you're putting numbers, it won't be that bad. Remember, you have 4 numbers that are given to you. 1, 2, 3, 4. And there's 1, 2, 3, 4 places to put those values in. You must put them in the proper location in order to get the correct slope.